Hi, I'm Shrishti Singh. My register number is UA14CS232. Today we are going to see our 10th experiment of a system software and compiler lab. Our 10th experiment is an intermediate code generation. Now, the aim of this experiment is to write a program to convert the given arithmetic expressions to 3 address code. Now, what we do in this program basically is this, that the compilation process which we do can be divided into a number of subtasks called phases, and intermediate code generation is one of the phases of the compiler. Now, once the syntactic constructs are determined, the compiler can generate object code for each construct, but the compiler creates an intermediate form. It helps in code optimization and also to make a clear-cut separation between machine-independent phrases, that is our lexical and syntax, and machine variables as the terminal nodes. Now, in this particular exercise, what we are doing is this. First, in the initial steps, we are importing a package. Our class is being declared. Now we are declaring a precedence rule. Now a precedence rule is this, that my division and my star will have the first preference, then my addition and subtraction will have my second preference. Now we'll be checking the precedence rule in the given string that we are giving. Now we are declaring a character token. Now we are assigning it as t.char at 0. Now in this, what we'll do, we'll check the token that is there with the precedence I. If that integer is matching with that precedence, we'll return that integer, that precedence value, else we'll give -1. Okay, now in this one, now I'm declaring my int as I, j and op count. Now my character as token. Now boolean, we are checking the process and the operators of the string. We are declaring a string expression as temporary, and we are having a new input for expression. Now in this, we'll check like if a plus b plus c, then which will have more preference, which one we'll continue from, which one we'll take first, then we'll go from left to right. Then we'll check the process. If the process I is equal to false, then a new boolean algebra length will be given to it. Now if my I equal to 0, I gives expression dot length I plus plus. Then if my token equal to expression dot char at. Now for my j, if my precedence length j plus plus. In this, we'll check the operators, that is my 0 and 1, the operators that we initialize according to the precedence rule, and we'll increase the op count, we'll increment the op count, and we'll break the particular. Now over here, for I equal to op count -1, I is greater than equal to 0, I minus minus. For j equal to 0, j is less than I, j plus plus. If my precedence operator, that is my j, is greater than my precedence operator j plus 1, then my operators j and 0 will be assigned to a temporary variable. And my operators j plus 1 will be given to operators, and my temporary operators will be j plus 1 0. Now over here, we'll print the now for printing the values, for I equal to 0, I gives op count I plus plus. Now over here, I'm using my integer dot parsing for my operators I and 1. If my opcode 1 is equal to my opcode 2, and if my check process j minus 1 is equal to 2, I'm so sorry, is equal to 2, then over here we'll be getting our opcode 1 value. Either it will be that string, from that string, or either it will be one of the characters. Now we'll check the process j plus 1. If it is true, the same will be happening for the output 2. So this is and finally we'll print the term with the operators, and we'll be checking the process. It will be printed after checking the process if it was true. Now we'll run this program and we'll see the output. It is telling to enter an expression. I'll be entering one expression like a plus bracket b minus c into bracket b minus c I'm so sorry, divided by g. As you can see, my t1 according to my preference, t2, then my T3, and then my T4 and T5. This is basically my 10th exercise of system software and compiler design to generate an intermediate code. Thank you.